All right, today's lesson is on solving one-step and two-step inequalities. We're just going to review a little bit just so that way we can see what's going on here, but a lot of this stuff is going to be pretty straightforward. So it says, for the following problems, graph the inequality and write your solution in interval notation. I want to graph the set of all my x's that are less than or equal to 3. So the first thing you're going to do is you're going to circle your boundary point. That 3 is the boundary point. I'm going to circle it. And I want x's that are less than or equal to 3. So like 2, 1, 0, -1. That means I want all the x's going this way. And the last thing we're going to check is, do I need to shade in that circle? Well, because there's an equal sign, I do need to shade it in. And so on a number line, this is what it would look like. As far as or interval notation, remember, we start from the left and go right. So where does it start on the left? It started way over here at negative infinity, and it stopped all the way to 3. So my boundary points are going to be from negative infinity to 3. Infinity always has a parentheses, and since the 3 is shaded in, we're going to use brackets on this end. That means the 3 is part of my set because I have that equal sign. On the next one, I'm going to go x is greater than -2. Just like before, we're going to go ahead and circle the -2. I want x's that are greater than -2, like what are some numbers that are greater than -2? Well, that would be -1, 0, 1, 2. That'd be all these numbers going this way. I'm going to go ahead and check to see if I need to shade in the circle. Well, because there's no equal sign, we don't shade it in. And then remember that for the interval notation, we're going to start on the left, which means we're going to start at -2. And at the right, it ends at positive infinity. Since the -2 is not shaded in, then I do not want it to be part of my set. So I'm going to go ahead and put a parentheses on it. And then the infinity symbol always has a parentheses on it as well. And then the last one, we're going to go a little faster. X is less than -1. Circle my boundary point. I want numbers that are less than -1, like -2, -3, -4, which means I'm going this way, all the way to negative infinity. So going from left to right, my boundary points would be from negative infinity all the way to -1. Parentheses on the infinities always, and since the one is not shaded in, then I leave it with parentheses as well. So let's just a little bit of review of the stuff we've done before. It says, remember that an inequality is a way of comparing the value of two different numbers in relation to each other. Since the value of 4 is less than 8, we can write that 4 is less than 8. For the following problems, what we're going to do is we're going to be testing different operations on this relation to see if the symbol is still valid afterwards. So I'm going to test each one of these, and I'm just going to follow the directions, and I want to see if I still get a true statement. So if I add a positive number to both sides, like let's say I add 3 to both sides. I know 4 is less than 8, but when I add 3 to both sides, I get 7 and I get 11. Is 7 less than 11? So that still holds, like, even though I added 3 to both sides, I still get a true statement, right? What if I add a negative number? Well, let's say I added like a -2 to both sides. 4 plus -2, I get 2. And 8 plus -2, that's 6. And notice that I still get 2 is less than 6. So I still have the left side still smaller than the right side. So that inequality still holds. What if I subtract a positive number? Like let's say I subtract 1 and I subtract 1. I know 4 is less than 8, but if I subtract 1, I got 3 and 7. And notice that that inequality is still working. So all these things that I'm doing to this inequality, the inequality symbol is staying the same. What if you subtract the negative? Like let's say I subtract a -4 on both sides. Well, remember that subtracting a -4 is the same thing as adding a +4. So this would be a 4 plus 4, which is 8, and then an 8 plus 4, which is 12, and that symbol stays the same. Okay, so far so good. I'm doing all these things to the inequality, and the inequality is staying the same. What if I multiply it by a positive number? Like let's say I multiply both sides by 3. 4 times 3, I get 12. 8 times 3, I get 24. 12 is less than 24, so this still stays the same. So multiplication so far seems to be working. I'm going to go ahead and multiply both sides by -3. 4 times 3, -3 is -12. And then 8 times -3 is -24. And if you try to say that -12 is less than -24, that would be incorrect. So let me go ahead and mark this with a red line through it, because this is not true. -12 is not less than -24. I don't like the way that turned out, so let me go ahead and cross it out this way. What I should be saying is that negative 12 is actually greater than negative 24. So in this one doesn't work as you would think, right? In this case, this is one of those cases where I did have to change the sign in order for my statement to stay true. So let's just keep that one in the back of our head. Like that was kind of weird. And let's say I divide by a positive number. Let's see what happens here. If I divide both sides by 2, 4 divided by 2, I get 2. 8 divided by 2, I get 4. 2 is less than 4. Okay, that works. So we're back on the good trend again. And let's go ahead and divide by a negative number. 4 divided by negative 2 and 8 divided by negative 2. 4 divided by negative 2 is going to be negative 2. 8 divided by negative 2 is negative 4. If you try to tell me that negative 2 is less than negative 4, that is not true. Negative 2 is actually a bigger number than negative 4. So again, we're running into this case where it didn't work. So it looked like everything pretty much worked except for this one right here, multiplying by a negative and dividing by a negative. All the other cases stayed the same, but when you multiply and divide by a negative, some weird stuff happens. So it says, notice that the inequality symbol stayed the same in every example except when you multiply or divide by a negative number. So multiplication property of inequalities, if you multiply or divide both sides of the inequality by a positive number of the inequality, then the inequality symbol stays the same. So if you divide or multiply by a positive number, then that symbol stays the same. You don't change it. However, if you're going to multiply or divide by a negative number, then that symbol changes direction. You need to flip whatever direction you had going on. So these rules are going to allow for us to solve for variables involving inequalities. Remember that the symbol will always stay the same unless you are multiplying or dividing by a negative number. In that case, you're going to need to change the direction of the sign. So we're going to treat it almost like an equal sign. Unless I'm multiplying or dividing by a negative number, then that's telling me I got to switch the sign, okay? For each of the following problems, solve for the variable, graph the solution set, and write down using interval notation. So let's go ahead and try this out. Again, we're going to try to treat that like an equal sign. We're going to keep that direction the same unless I multiply or divide by a negative number. So if this would have been an equal sign, I want to get x by itself. I need to get rid of the plus 3. How do you get rid of a plus 3? Well, we get rid of a plus 3 by subtracting 3 on each side. These are going to cancel, and I get x is greater than or equal to negative 2. Looks like I solved x, and I didn't multiply or divide by negative, so I'm going to go ahead and keep the sign the same. How do I graph this? Remember that we're going to start at negative 2. I need numbers that are greater than negative 2, like 0, 1, 2, 3. These are all numbers that are greater than negative 2. So my solution set goes like that. Should I shade it in? I absolutely should shade it in because there's an equal sign down there. And now I'm going to go ahead and graph my solution set using interval notation. I'm going to start at negative 2, and I'm going to put a bracket on it because I have it filled in. And this goes all the way to positive infinity, so this goes like this, parentheses on the infinity, just like before. All right, let's try this next one. This next one, I know I'm going to get some of you guys on. That says x times 4. So I need to get rid of the times 4 by doing the opposite, which is dividing by 4 on both sides. These are going to cancel. Now, I want you to understand what happened here. I took my x. Well, first of all, negative 12 divided by 4 is negative 3. I took my x and I divided it by 4. I did not divide by a negative number. I divided by a positive number. So in this case, the direction of the symbol does not change. We leave it alone. I know some of us are going to look at that negative 12 and say, but that's negative. That's okay. As long as we're not multiplying or dividing by a negative. In this case, I'm dividing by a positive 4. That symbol stays the same. So we're going to leave it as x is less than negative 3. I'm going to circle the negative 3. I need x's that are less than negative 3, like negative 4, negative 5. That means this set started at negative infinity. So negative infinity all the way up to negative 3, parentheses on the negative infinity always, and parentheses on the negative 3 because I did not have an equal sign in that inequality. And then our last example on this page says negative 4x is less than or equal to negative 12. Very similar to the last one, except this time I am multiplying by negative 4, which means I need to do the opposite, which means I need to divide by negative 4. Since I am dividing by a -4, I need to change the direction of that inequality. First of all, -12 divided by -4 is +3, and we're going to change the direction of that inequality. So now it's going to go the other way because of the rule that we said above. I got x is greater than or equal to 3. We're going to go ahead and circle the 3. I need numbers that are greater than 3, so we're going to go 4, 5, 6, and so on. Do I shade in the 3? Yes, because I had an equal sign. This set started at 3 and ended all the way at infinity. So I need a bracket on the 3 because it's shaded in and parentheses on the infinity. All right, we're going to do 3 more problems, and then we're going to move over to some more difficult stuff, but not really. X divided by 3 is greater than -1. How do I get rid of a divide by 3? I multiply both sides by 3. These are going to cancel. I know -1 times 3 is -3. Do I need to change the symbol? Well, what did I multiply by? I multiplied by a +3. Multiplying by a positive is okay. We're going to leave the symbol the same. So I need all my x's that are greater than -3. Here is -3. I need numbers that are greater than -3, which means I'm going this way. And as far as my symbols are concerned, this ends at positive infinity. So I'm going to write -3 to infinity, put parentheses on the -3 because it's not filled in, and then put parentheses on the infinity because we always do that. All right, this one is going to give us a little bit of trouble too. I got -4 is less than x minus 5. I'm going to go ahead and add 5 to both sides. These are going to cancel. I get 1 is less than x because I keep the symbol the same. Now, students will get this confused because the x is on the right. I honestly hate having the x's on the right. So I'm going to flip that whole thing and make the x on the left. And I'm literally going to reverse it. So instead of writing 1 is less than x, I'm going to reverse the entire statement and say x is greater than 1. That allows me to know that this starts at 1 and I need x's that are greater than 1, which means I need to go this direction, which is maybe opposite of what you think it would have been, right? Where does this start? This starts at 1 and it ends at infinity. I need a parentheses and a parentheses because the 1 is not shaded in and infinities always involve parentheses. All right, last one. I have x over -5 is greater than or equal to -1. We're going to multiply both sides by -5. Because I'm multiplying both sides by -5, that symbol needs to switch. So I'm going to write x greater than, I just said that symbol needs to switch. So we're going to go ahead and flip that to a less than or equal to, and the -1 times -5, that's a +5. I'm going to go ahead and circle my boundary point. My boundary point is at +5. It's over here. I'm going to circle it. I'm going to shade it in, and I need all the x's that are less than 5. That would be going in this direction all the way to -infinity. So what are my boundary points from -infinity to +5? Parentheses on infinity is always, and since that 5 has a shaded in region, we're going to go ahead and put that in a bracket. All right, so that takes care of the first 6 examples, and hopefully you're okay with that. We're going to do 4 more examples, but this time we're just going to do 2-step problems. So solving 2-step inequalities is just like solving 2-step equations. Just remember that the direction of the inequality will always stay the same unless you multiply or divide by a negative number. I'm going to keep highlighting that until we get that in our heads. That's so important. Okay, the only time we have to switch that sign is when we multiply or divide by a negative number. If you're adding or subtracting, you're going to leave it alone. All right, so if this would have been an equal sign, what would we do? Well, the first thing we'd do is we'd get rid of the 5, right? Right now, the -2x is grouped, and I'm going to get rid of the +5. How do we get rid of +5? It's with a -5. These are going to cancel each other out. I'm left with the -2x. That symbol stays the same because I did not multiply or divide by a negative. It is 6. I just, oh no, we're good. So I got -2x is greater than 6. What's my next step? I'm going to get rid of that -2 by dividing both sides by -2. Hey, right here, I am dividing by -2. Since I am dividing by -2, then that sign needs to switch. So the -2's are going to cancel. I get x is less than -3. I'm going to go ahead and graph that solution set. Here's -3. I need my x's to be less than -3. And in this case, it did not tell me to write it in interval notation, so I am set. Here, I got x plus 23 divided by 2, and I got 13 on the other side. I need to remember that when we group this, we're grouping the x plus 23 is together, so I need to get rid of the divide by 2. How do I get rid of the divide by 2? I multiply both sides by 2. Do I need to change the symbol? No, because I'm multiplying by a positive 2, and that's okay. We're going to go ahead and cancel these out. This is going to give me 26 is greater than or equal to x plus 23. The next thing I need to get rid of is the plus 23, so I get rid of it with a minus 23. Since I'm subtracting, that symbol still stays the same. These are going to cancel each other out. I'm left with 3 is greater than or equal to x. I do not like it when the x is on the right. So we're going to reverse this, like completely reverse this. So instead of saying that x is greater than or equal to 3, I'm going to write the exact opposite. X is less than or equal to 3. That makes it a lot easier to kind of see where my set should be. Here's my boundary point at 3. I want x's that are less than 3, so that'd be 2, 1, 0, and so on. And because there's an equal sign down there, I need to go ahead and shade this in. And since they did not ask me for interval notation, we're going to leave it as is. Okay. Hey, on this one, there's actually a couple different ways you can do it, but what I've taught you to be consistent is to distribute that 4, right? So I think we're going to go ahead and stick with that. I'm going to distribute the 4. 4 times 7x, that gives me a 28x minus 44 is less than 12. All right, notice that the 28 and the x are grouped together, so I need to get rid of the negative 44. How do I get rid of a negative 44? Well, I add 44 to both sides. These are going to cancel. I get 28x is less than 56. I do not change the sign because I did not add or, I'm sorry, did not multiply or divide by a negative. Now I'm going to get rid of the times 28. I can get rid of the times 28 by dividing both sides by 28. Do I change the symbol? No, because I'm dividing by a positive number and that's okay. So this becomes x is less than 2. I circle the 2. I want x's that are less than 2. That's going to go this way. And I do not shade in the 2 because there is no equal sign underneath the 2. And then we're down to our final one. I got x minus 5 over negative 3 is less than or equal to 2. I notice that I have this x minus 5 grouped together, so I'm going to go ahead and get rid of the divide by negative 3. I'm going to multiply both sides by negative 3. Since I am multiplying both sides by negative 3, that symbol needs to change. So these are going to cancel. I'm left with an x minus 5. That symbol needs to change to greater than or equal to, and then 2 times negative 3 is going to give me a negative 6. Last step is to add 5 to both sides. These are going to cancel. I get x is greater than or equal to negative 1. I need all my x's to be greater than or equal to negative 1, so I'm going to circle the negative 1. I need x's to be bigger than that, so I'm going to go this way. And since there's an equal sign on the negative 1, I'm going to go ahead and shade it in. Okay, those are all the problems that we have for today. Hopefully that helps. If you have any questions, as always, feel free to ask.